Welcome to this week's midweek space news. So first of all, you can find us on X at Space Startup Hub. So I post my videos on there and also sometimes reply and comment. So please follow us on there if you're on X. And let's get into the first article I found this week. If I bring it up here. Here it is. And this is an article from European Spaceflight by Andrew Parsonson. And it's on RFA, that's Rocket Factory Augsburg, a German space startup that's been awarded a flight ticket initiative launch contract from ESA, that's the European Space Agency. So let's have a quick read. I've just marked up some of the article. German rocket builder Rocket Factory Augsburg, and they're commonly referred to as RFA, has been awarded launch service contracts for 2 missions under the flight ticket initiative. So these are subsidized launch opportunities for European companies and organizations on small launch vehicles. So the pre-selected pool of launch providers are Arianespace. So it's a very large European consortium. It's not a startup at all. You have ESA Aerospace. So ESA Aerospace have flown once. It lasted 30 seconds before crashing. They are very close to launching a second time. So it could be next month or it could be March of this year. PLD Space should be launching this year. Orbex looks like it will be bought by the exploration company, and my next video this week will be on that, so I won't say much more about that at the moment. And then you have RFA, Rocket Factory Augsburg. So they've won a contract, and it's for 2 missions comprising a total of 3 satellites. So both missions will be launched aboard a single RFA-1 flight. RFA-1 is the name of their rocket. They have now been selected for 4 launches, 4 missions aboard its RFA-1 rocket. So that is the article from European Spaceflight. Okay, let's talk about RFA, Rocket Factory Augsburg. We have this video playing in the background here. So they are launching from Saxavord, which is in the Shetland Islands, north of Scotland. So there's a ferry and the rocket's on there, heading towards the spaceport. So they have a launch pad already, them testing their rocket in 2024. They're hoping to launch in 2026 this year. There was an anomaly at the end of 2024, quite a serious one, and that's pushed back the schedule a bit. But hopefully they can get off the launch pad this time round. We can actually look at the anomaly. So you can see, it just, an engine caught fire, and the fire suppression system wasn't strong enough to put out the fire, and it just spread, and it just got worse. So they lost the first stage, they lost all the engines on the rocket, and it's quite a serious anomaly. Luckily, the launch pad itself, which is quite robust, is fine. So they're working on the second rocket, some new engines, and there's some more angles of the failure. So this is the CEO explaining what went wrong. Kudos to him for showing this video. We can see exactly what happened. If we look at their vehicle, this is a render of what it looked like. It's called RFA-1. It's a German space startup. We have this graphic so you can see the first stage, second stage, and then you've got this kick stage. Think of it as a space tug called Redshift. We have some images of the 9 engines, I believe. Then we have a shot of the Saxavord spaceport. As you can see, it's a very remote location. RFA will be launching from here. Orbex, Skyrover, maybe High Impulse as well. So quite a few European space startups should be launching from Saxavord at some point. I expect Skyrover to launch for sure this year, although that would be suborbital. In addition, they're working on cargo vehicles. You can see it approaching probably the ISS. Here's another render here. They were in a competition for missions to the International Space Station funded by Europe. That competition was won by the European Exploration Company, but RFA did bid. So this is the third stage, kick stage called Redshift. And they have plans in the future for perhaps larger rockets. This was just a concept design for larger rockets. It's not planned at the moment. So we'll see what happens with RFA. It's good that they're getting contracts from the European Space Agency. Obviously, they do need private contracts in the future. So hopefully in 2026, make their first launch attempt. And we should be seeing ESA Aerospace's second launch attempt perhaps in a month or 2. So let's move on to our second story. Okay, there's a few news articles on Mega-constellations which I want to talk about. And then there's a space startup contract that I think is connected and relevant. So let's first talk about the mega-constellations. So this is from the FT Financial Times, and it's on Rheinmetall and OHB in talks over Starlink-style service for German army. So Rheinmetall, they generally build defense equipment and artillery shells, but they are moving into the space sector because there's just so much money there. So this article says they're building an equivalent to Elon Musk's Starlink internet service for the German armed services. So Berlin, so that's Germany, has a 35 billion budget for military space technology. The proposed joint venture would bid for a multi-billion euro contract to create a secure military-grade satellite communications network in low Earth orbit. FT goes on to say the European defense and space companies are jostling for lucrative contracts after Berlin last year promised to pour 35 billion euros into military space technology. And Germany is rapidly expanding its military capabilities and reducing its reliance on the US. Many countries are nervous of relying on Musk or the US and want to develop their own secure and sovereign networks. The Bundeswehr, which is the German army, wants a network that will be built over the next few years and will be primarily German companies. So that could benefit ESA Aerospace and Rocket Factory Augsburg, which are both German space startups. They're not quite at the stage where they can launch a mega constellation, but if they make progress this year, potentially they'll get contracts from the German government, in the next couple of years. So that's very promising for those two startups. And it goes on to say Rheinmetall has traditionally made tanks, artillery, and ammunition, but is rapidly moving into other domains as Germany has boosted its defense budget. That is the first article on mega constellations. But before we talk about a space startup, I want to bring up another article on mega constellations, which I think is relevant. Let me just share that article, and it's on Space News. So let's read this. So it says China outlines mega constellations in ITU satellite filing. So China has submitted plans for more than 200,000 satellites as the global competition for low Earth orbit intensifies. So there are dozens of planned satellite constellations. The largest proposed systems, designated CTC-1 and CTC-2, each list 96,714 satellites. The large number of planned satellites reflect China's readiness to undertake extensive, coordinated deployment in low Earth orbit. And at the bottom it says, multiple countries are submitting proposals for constellations numbering more than 100,000 satellites. So that just gives you an idea of the scale of satellite deployment for these mega constellations. It's not just China, it's the US, it's Europe, and probably many other countries that are involved in launching these mega constellations. So we already have SpaceX's Starlink. We have the Amazon Kuiper mission, which I think has been renamed Leo. We have Iris 2 from the European Space Agency or the European Union. We have this Rheinmetall mega constellation. We have OneWeb, and we have probably 10 Chinese mega constellations representing hundreds of thousands of satellites. That leads us on to the next story, which is on Starfish Space. I'll put myself in the corner. And they posted on X, we're proud to share that Starship has been awarded the first end-of-life disposal contract for a low Earth orbit satellite constellation in history. This $52.5 million contract from the Space Development Agency allows us to build, launch, and operate an Otter, which is one of their small satellites, to provide end-of-life services for the SDA's proliferated warfighter space architecture, maximizing the capabilities the constellation can deliver for the warfighter. And we have an article from Payload Space, so let's bring that up. So the article says, Starfish wins SDA deorbit as a service contract. The Space Force is tapping Starfish Space to take out its trash in orbit. A $52.5 million contract to deorbit satellites. Starfish says this marks the first contracted mission for end-of-life satellite disposal services, and Starfish is set to launch an Otter spacecraft, more on that later, which can deorbit multiple sats in one flight for the mission in 2027. Under the contract, the Department of Defense can keep buying services to take down defunct sats beyond the initial deorbit. Deorbiting sats helps the SDA fly its constellations as long as possible. It allows them to continually dodge satellites, which can empty out fuel tanks quickly. DoD keeps the orbital lanes open for those sats still fulfilling their missions, and having a deorbit service at the ready allows the SDA to fly sats until they're truly dead. The tech is ready to go, and there is an economic benefit to disposal services. And we have this quote at the end of the article: "It's hard to be the first, but it's easy to be the second." So that's the article, and it makes a good point about you can fly the satellites for longer, because normally what you have to do is you have to keep a reserve of fuel in the tank because you have to deorbit the satellite. But if you bought a deorbit service contract, you don't have to do that. You can use all the fuel in the tank until it's completely empty. So your satellite can last for longer, and then you just pay for it to be disposed. So this is potentially, if it works, it's very useful for the US Space Force, the SDA, Department of Defense, and even commercial companies with mega-constellations. If they don't have to deorbit the satellite, it can stay on station longer. And there's not the worry that you get a lot of orbital debris if there's a problem. You just have a deorbit as a service contract, Starfish, Astroscale, or ClearSpace, or one of the other space startups, and they'll just take care of the satellite once it's finished its mission, or it stops responding. So that's the idea. So a little more on Starfish Space. This is their Otto pup. So this is like a tech demo. It's a scaled down version of their full Otter satellite. And you can see it here on a rideshare mission on a SpaceX transporter mission. And we have a look at the systems on board the Otter satellite. You have the guidance, navigation, and control software. You have the visual camera that is used to rendezvous and dock with a satellite. You have the docking system. Then you have this to be revealed. But you can actually see it's a robotic arm. It's a remote manipulator. And you can see it a little better in this here. So you can see the arm extending out. It's got a camera on the end. So you can use that for inspecting a satellite, either your own satellite, perhaps a satellite from another country. So that's obviously a very useful piece of technology. And we have this graphic here, Starfish upcoming missions. So there's a tech demo for Autopup 2. And then we have Spicy, that this is a NASA contract to deorbit 2 defunct NASA satellites, which is worth $15 million. So that should be launching at the end of 2026. Then you have an undisclosed satellites from the US Space Force, which is worth $37.5 million. That's also this year. Then you have a contract with Intelsat for the servicing of 2 satellites. And the contract size is undisclosed. And again, that's this year. There are quite a few missions contracted for the US government and also Intelsat, which is a private commercial company. So let's hope the technology works. And there's obviously other space startups that are involved in this as well. I mentioned Astroscale and ClearSpace. But the reason I mentioned about all the mega constellations is this is just one service, which is the deorbit service. Another service is satellite servicing. You could refuel perhaps, you could upgrade components or repair components. And another service is potentially melting down a satellite once it's finished its mission, or collecting spent upper stages, sending them to a in-space metal foundry, and then repurposing them into orbital infrastructure or into metal propellant rods, which could then be used for propulsion. I mentioned Newman Space and also MagDrive in the UK, both that use metal propellant rods for propulsion. So you've got this whole in-space ecosystem that can take advantage of spent upper stages or defunct satellites from mega constellations. Either you deorbit them or you melt them down into something more useful and use them for propulsion or for orbital infrastructure. Also, you could send them on a lunar impact trajectory and then recycled aluminium for lunar base construction. And I've got videos on all those topics, so please check them out. But the idea is with hundreds of thousands of satellites likely to be launched, you're going to get a lot of spent upper stages, especially from Chinese launches, and also a lot of potentially dead satellites that need to be removed or repurposed. It's all very interesting. I think, as I mentioned the other day, that the bottleneck for the orbital economy is no longer launch. That's a solved problem with SpaceX, Falcon 9, and a whole range of other space startups that will be launching soon. You have Rocket Lab's Neutron, you have Stoke Space, you have Relativity Space, then you have the European startups, ESA Aerospace, PLD Space, you have InnoSpace from South Korea, you have Interstellar and Space One from Japan. So there's a lot of space startups. The bottleneck is now orbital infrastructure. We need the orbital destinations, and we need to start building infrastructure in space. Taking advantage of the 10,000 tons of orbital debris that's already in low Earth orbit would allow us to build a lot of orbital infrastructure. So it's all very interesting and very exciting. So that's it for this week. I've covered all the topics, and my next video, probably out on Friday, will be the news that the exploration company is likely to buy Orbex. So the exploration company is a French-German startup that's working on cargo vehicles. They're now buying a launch provider from the UK. So they are now going full stack. You're beginning to see European consolidation in the space sector. The exploration company will now have a launch vehicle, and they will now have a cargo vehicle, and they are vertically integrating in the technology. So that's very interesting. So I'll talk about that on Friday. So thank you for watching, and I'll see you next time.